Hello, Year 5. How are we all? Have we all had a lovely half term and have we all relaxed and given our eyes a rest from technology and computer screens over half term? I hope you have all managed to have a nice relaxing half term. You had such a struggle last term getting through all of that work and having to change your entire learning attitude to be doing it at home, but you did really, really, really well. And hopefully we'll be back at school before this half term's over. Let's keep our fingers crossed, Year 5. Let's keep them crossed. So we're going to crack on and carry on with our fractions work. This is quite a big unit of work, this one. And today we're going to be looking at adding and subtracting fractions, okay? So this is going back to all of our converting mixed numbers into improper fractions and then working out the answers. So before we do that, let's warm your brains up a little bit. So what I want you to do is pause the video, set yourself a 5-minute timer, okay? I want you to have a go at doing these multiplication questions for me. So pause the video, 5 minutes, have a go. Okay, so how much juice is in each glass? If 835 millilitres is poured equally, we know if we're sharing something equally, we've got to divide it. Again, the answer would give us 167 millilitres. Work out 38 times by 23, that's 870. Work out 20 multiplied by 60. We can cheat and do our SMART method. 2 times 6 is 12. We've multiplied both by 10, so we've got to multiply it by 100, 1,200. How much does Milo spend in total? We've just got to add them all together. And the answer gives us 165. So well done if you got those right. If you didn't get some of those right and you made some mistakes, go back and do some corrections and work out where it is that you went wrong so you can remember for next time. Anyone that's done the time here, we can see that it is, I want to say it's 25 past 8. Yes, 25 past 8. So that was going to give us 8:25. Or if it's going to be in 24-hour clock, it's going to be 20:25 because the 20 is 8 in military time, okay? So well done if you got those all correct. Now, let's warm up your brains with some fractions, okay, because this is what we're going to be focusing on today. So what I want you to do is I want you to pause the video, give yourselves 5 minutes, I reckon you'll do it quicker than 5 minutes, and have a go at these questions. Okay, easy peasy. 5 apples is 2 apples. Well, we know that's 7 apples. 5 thirds add 2 thirds. Well, we know that's going to be 7 thirds. Here, if we're taking away, our denominators don't change. When we're taking or adding away, if our denominators are the same, we don't do anything, so we just focus on our numerators. So 7 take away 4 here, it's going to give us 3/9. That is also the same as a third if anyone converted it to a simplified fraction. Here we can see 8 11ths take away 5 11ths take away 1. Well, first of all, let's take away 5. That leaves us with 3. Take away 1 leaves us with 2/11. So well done if you got those all correct. And that's going to help you with that work that we're going to look at today. So Dexter eats 2/5 of his chocolate bar. Okay. And Alex eats 4/5 of her chocolate bar. Now my question is, do they eat more than one whole bar of chocolate between them? Okay, so let's show this as a chocolate bar. So here is Dexter's bar. Okay, now it's 5 equal parts because our denominator is 5, and the numerator here tells us well he's eaten 2. So we're going to shade in 2/3 of them. This is Alex's chocolate bar. Now Alex has eaten 4 pieces of his chocolate bar. So between the two of them, what's the fraction of chocolate that they eat? Okay, so they've eaten 6 pieces between the two of them. So they've eaten 6/5 of a chocolate bar. Now, we know just from looking at that fraction that that's more than a whole bar, because a whole bar would be 5/5. And we know, because this is now an improper fraction, our numerator is bigger, which means we've gone beyond the point of our whole. Okay, so if we actually move this piece of chocolate, we can see we've got 5 pieces there that's been eaten. So we've got one whole chocolate bar and one piece that's been left over. Now, if we'd done that without the bars, we'd have known that was more, because 5 into 6 goes once. And then we've got the remainder. Okay, it's a bit like our dividing. How many 5s are in 6? Well, 1. Well, how do we get from 5 to 6? There's 1 left over. So it's 1 whole and 1/5. So the answer to this question is yes. Between the two of them, they've eaten more than one whole chocolate bar. So thinking about that same principle, pause the video and have a think. Well, how might we work this one out? What's my improper fraction going to be? And is it going to turn into a mixed number? Pause the video and have a go. Okay, well, our denominators are staying the same. So we just simply do, well, 3 add 6. Well, that's going to give us 9/7. I mean, think, well, how do we get from 9/7 and turn that into a proper fraction? So we need to think, well, how many 7s are there in 9? Well, we know that we can get 1. How many's left over? 2. So it's 1 and 2/7. Now, let's show you this as a part whole model. So we've got our whole fraction over here. We need to think, well, how many wholes have we got and what's left over? So we're going to divide it. Well, can I get a 7 out of 9? How many 7s are in 9? Good, 1. Now 1 whole would be 7 over 7, wouldn't it? Okay, now we can't write 7 over 7 when we're turning it into a proper fraction, a mixed number, so we've got to turn it into a whole number. We know that 7 over 7 is the same as a whole, so if we've got our 2 7s left over, we can exchange that whole one there for 1 whole. And then to get from 7 to 9, we had 2 left over, and that's what gives us our mixed number. So let's see if we can do the same thing here. So again, our numerators stay the same. We've got 3 add 3, well that's 6. 6 add 7 is going to give us 13 over 18. So let's put that into our bar model, into our part whole. Okay, can I get 8 out of 13? How many 8s can I get from 13? Good, I can get 1. So I can get 8 lots of 8, or 8 eighths, effectively. Okay, now leftovers, how do I get from 8 to 13? Well, I've got 5 left over, so I've got 5 eighths. Now we don't write 8 eighths like that when it's a whole one, so we need to exchange that as a whole. So our whole number is going to be 1, and our fraction is going to be 5 eighths. So our mixed number is 1 and 5 eighths. With me so far? Good. Pause the video. I want you to have a go at doing this one on your own. Okay, so we add them together. 10 add 8 add 6 is going to be 24 out of 11. Now, let's put this into a part whole. Now, you might be thinking, why has Miss Humphrey put it into 3? Well, if you do your 11 times tables, okay, how many 11s can I get in 24? We've got 11, 22. Well, I can't go to 33, but I've got 2 lots of 11, okay? So if I have 11, 11, that's 1 whole, but I can get another lot of 11, 11, so that's another whole. So far I've got 22. I've got 2 lots of 11, 1 lot of 11, 2 lots of 11. That's 22. So then I think, well, how do I get from 22 to 24? I've got 2 left over. So I've got 2 11ths. So if I now write this as a mixed number, I've got 2 wholes, okay, and I've got 2 11ths left over. Easy peasy, lemon squeezy. Now let's see how we do this one. This one is a takeaway. Same rules apply. Our denominators aren't changing. Our numerators are different, but our denominators are the same. So 11 take away 2. Okay, so here's our bar models. We've got 11. We take away 2. Easy peasy. 9 over 8. How do we write that as a mixed number? Well, how many 8s can I get in 9? Well, I can get 1 8. So I've got 1 whole. How many is going to be left over? I've got 1 left over. Okay, so then I've got 1 8th. Okay. Now, based on that, you've got your 2 bars here to represent it for you. Pause the video and have a go at doing this one. Okay, well, 7 take away 1 is easy. That's 6 over 4. Okay, now if we write this as a mixed number, how many 4s are in 6? Well, we know we can get 1 lot of 4. How do we get from 4 to 6 then? Well, it's got 2 left over. So we've got 4 over 4, so we've got our whole and 2 4s left over. Now, we can change this fraction and simplify it any further. Rather than it being 1 and 2 quarters, going back to our equivalent fractions, does anyone know what an equivalent fraction is to 2 quarters? Good, it's the same as a half, isn't it? Okay, 2 into 4 goes once, 2 into 2 goes once, 2 into 4 goes twice, that's 1 over 2. So that's the same as saying a half. So I could turn this into 1 and a half. Equally though, if I was to write 1 and 2 quarters, that's fine, that's still correct, but I've managed to simplify it even further, okay? So pause the video and see if you can have a go at doing this one. Okay, so first of all, we're going to do this first bit first. So 21 take away 2, that's going to give us 19. Then we're going to take away the 3, that's going to give us 16 over 5, or 16 fifths. So now I'm going to think, well, how do I write this as a mixed number? So let's count on our 5 times table. It's got 5, 10, 15, well, we can't go any further. We've got 5, 10, 15, we've got 3 whole lots of 5. And then I think, well, I'm on 15 because I've got 3 lots of 5. How do I get from 15 to 16? I've got 1 left over. So it's 1/5, okay? Remembering that denominator doesn't change, okay? So what I want you to do now is I want you to pause the video and have a go at doing questions 1 to 3 on your worksheet. Okay, so here we've got missing numbers, okay? So bear with me for this one. Okay, so we need to work out how we work our way backwards to that missing box. So first of all, let's consider our answer. Our consider is 4 wholes. But I need to know, well, 4 wholes of what? Now, usually that links to our denominators. Now, our denominator is 5, so I've got 4 lots of 5 here. So I know that 4 lots of 5, okay, is going to give me 20 over 5, because 1 whole would be 5, 5, then 10, 15, 20. So 4 here is the same as saying 20 over 5. Now, this is the answer to a bigger number, because we've had to take away to get to this answer. Now, if I had to take away to get to the answer, How do I work out how to get to the original one? Might I do the inverse? What's the inverse of subtract? Good. Add. So we're now going to work this backwards. We're going to do the inverse. So we're going to do 20, add the 8. That's going to give us 28. Okay. Then we're going to go from our 8 to our 7. Okay. So I've got 20, add my 28. So now I go, well, how do I get from 28, add my 7? That's going to give me 35. Okay, now to check this, let's do it backwards. Well, 35 take away 7 gives me 28. 28 take away 8 gives me 20. And 20 is the same as 5, 10, 15, 20. 4 lots of 5. Okay, so all we need to do there is we do the inverse to get back to that original answer. Okay, now let's see if we can work out this one. Now, the symbol here in the middle is equal to, which means the total of this sum has got to be the same as the total of this sum. Okay, so let's work this one out first. 5 add 1 is 6. That's going to be 6 halves. Now, if I work this out as a whole number, I've got 2, 4, 6. So I've actually got 3 wholes, which means the total on this side needs to be 3 wholes as well. Now, this was 3 lots of 2 because my denominator was 2. But over here, it's got to be 3 lots of 9. Now, I know that if I do my 9 times tables, I've got 9, 18, 27. So my total has got to be 27 ninths. Okay? So I need to think to myself, well, how do I get from 27 from 14? So I can subtract. I can do 27 take away 14 because that's going to give me my missing number of 13. And the only way to check, add those two together. 14 add 13 gives us 27. So that symbol in the middle tells me they've got to be equal on both sides. We need to check what the whole lots would be for each denominator. Okay, so just pause the video and have a think. How do we work out the missing numbers here? Okay, well, this one at the top is easy. 4 lots of 6 is going to give us 24. And we need to think, well, how do we get from 29 to 24? We've got to take away 5. My missing number there is 5. Now, here we can work it out on this side. Okay, so here we can see that 17 take away 2 is 15 over 3. That's the same as saying 5 whole lots of 3. So I need 5 whole lots of this denominator. So I need 5 lots of 10, which is going to be 50. So I need to think, well, how do I get from 17 to 50? What do I need to add here? So let's do the inverse. 50, take away that missing 17, is going to give us the answer 33. Well done if you got those correct. Now we're going to do a quick problem solving question, and bear with me whilst we do this. Mo and Tommy each have a jug of milk. Now Mo's jug contains 5/7 less than Tommy's, but the total between Mo and Tommy, they've got 2 jugs, which is 3 2/7 of litres of milk. And we need to work out, well, how much milk does Mo have? So let's draw 2 bars. Bar model's really going to help us here. So here's Mo's bar and here's Tommy's bar. Now we know that Tommy's bar has to be bigger because the question told us that Mo has got 5/7 less than Tommy. So his bar's got to be smaller. Now that gap there is going to be that 5/7. So between Mo and Tommy, they've got 3 2/7. And that missing gap there is 5/7 because it told us that Mo had 5/7 less than Tommy did. So we need to think to ourselves, well, how can we work out what the difference is? Now, what we could do is we could make Mo and Tommy's bar equal. So what we could do is we could take away that 5/7 off Tommy's as well. That way, they've both got an equal amount. Now, if we took that away, that's going to tell us what Mo's bar is here. So if we took our total, it's going to be 3 2/7, take away 5/7. That's going to tell us what's left over for Mo. Now I'm looking at a mixed number here and a normal fraction. So what do I need to do? Okay, I need to turn them into normal fractions. So this one's going to have to become an improper fraction. So remember what we do is we multiply by the denominator and add the numerator. So 3 times 7 is 21. Add the denominator is going to be 23. So we've got 23/7 altogether. And we're going to take that 5/7 away. That's going to give us 18/7. So far between Mo and Tommy, they've now only got 18/7. But I need to split that between 2 of them, so I've got to divide that. So if I divide the 18, that's going to give me 9/7, and so will Tommy. So to answer my question, how much milk does Mo have? Well, we know that he's got 9/7, okay? Which is the same as saying 1 whole, because we can get 1 lot of 7, and we have got 2 remaining, so it'd be 2/7, okay? So bar model is really helpful there. So just take away that extra bit and make those bars equal, okay? What I want you to do now is have a go at doing questions 4 to 7 on your worksheet. If you struggle with questions 4 to 7, there are some additional questions I sent home to you for the emerging and greater depth ones. Have a go at doing those ones instead if you struggle with questions 4 to 7, okay? See if it helps you and then go back and have a go. All right, good luck, year 5.